welcome to the very last live session of virtual Regeneron ISEF. Thanks for joining us. I am Anna Rhymes, and I manage the Science News in High Schools program for the Society for Science in the Public. This program is one of the Society's outreach and equity programs and brings our award-winning science news journalism and related educator resources to almost 5,000 schools this year. As you already know or may have guessed from this International Science and Engineering event, at the Society, we're dedicated to expanding scientific literacy, effective STEM education, and scientific research. In addition to publishing our science journalism for almost 100 years now, our research competitions and outreach and equity programs provide opportunities that support the growth of students and teachers. All of our session speakers today are an integral part of the Society's educator community. Not only have they mentored students to our competitions, but they have also mentored and led other research teachers in our advocate program and at our research teachers conference. Additionally, they are all active members of the Science News in High Schools program and have been for a few years now. In short, we brought you a team of all-stars for the last live session. In this session titled Teaching Research for Students, you will hear these three expert research teachers talk about how students can develop an identity in STEM by engaging in scientific research. They will share their own experiences and what has worked well for their students in the areas of peer recruitment, lab management, student leadership, and student authorship and publishing. As a former science high school teacher, I am thrilled to introduce our teacher speakers today. Once introduced, the speaker will tell you a little bit about her background and about her teaching experience. First up is Amy Hammett, who teaches in Mays High School in Mays, Kansas. Amy?
Hi, everybody. I'm been a teacher now since 2006. I was once a data scientist. I still do some data science off on the side. I'm really passionate about students doing authentic science. And about 10 years ago, I developed the first science research class in Wichita for Wichita Public Schools. Brought that over. I went over to Mays about 6 years ago, and I've been a professional development leader in the next generation science standards collaboration between Missouri, Iowa, Nebraska, Kansas, Colorado, and sometimes Oklahoma. I'm a NASA data reviewer. I'm a Tinker Fellow for the Concord Consortium, and I also work with Microsoft, launching data science education, machine learning, and AI. So authentic science, I've got some great things to share with you guys that I think will help you to get students, or get yourself if you are a student, involved in some authentic science research.
Great, thanks Amy. And next up is Jennifer Claudio, who teaches at Oak Grove High School in San Jose, California.
Hi, my name is Jennifer Claudio. I teach at Oak Grove High School in San Jose, California, and I teach forensic science, AP biology, and science research. I've had science research students for the last several years, and I became affiliated with the Society for Science and the Public through the Advocate Grant Program in 2017 and the Research Teachers Conference in 2018. Some of my other affiliations include curricular units for the Yale National Initiative, doing bioinformatics at NASA Ames Research Center for the Gene Lab for High Schools program, and participating with the Tech User Group for the world of typesetting and typography. And I'm happy to be here today.
Thanks, Jennifer. And then last but not least, we have Katie Gazda, who teaches at Red Mountain High School in Mesa, Arizona.
Hello, everyone. I've been teaching in Arizona for the last 12 years, and I've always had a passion for unique, original student research. In the last 4 years, I've helped my students start to go national. I got associated with the Society for Science with the Research Teacher Conference in 2018, and if there's any teachers out there, I really encourage you to look into that. It is one of the most affirming, motivating conferences I've ever attended. And I'm just very glad to be here today. I do teach science, mainly biotechnology, but have dabbled in research, biomedical innovation, and many other courses.
Great. So thank you all again for agreeing to be here and making our first ever virtual ISEF a real success. We really appreciate it. So now I'm going to hand it over to the presenters for about 25 minutes, and then after that we'll have about a 15-minute question and answer session So audience, please submit your questions via the chat box throughout the presentation, and then we'll collect and queue up those questions for the presenter. All right, so Amy is going to start us off.
Here we go. I've already told you a little bit about myself, but one of the things that's most important for you to know about me is that authentic science in science class is really the greatest passion of my life. Getting kids to work on real world problems led me to get involved with ISEF about 3 years ago by going to a research teachers conference and presenting on big data, equity in science education, and authentic science research. So I want to introduce you to some of my students today and some of the work that we've done in a project that I developed a couple of years ago because I was having some trouble getting kids to do science research projects, not having class time during the day to work on those kinds of things. So I wanted to tell you a little bit about this project that we started in 2018, where I had a bunch of kids who were really bright, actually all ability levels, who had some really great ideas about what to do with some of the problems we have in the world today, but really didn't have a lot of time or motivation to take on an independent science research project. So I started to look for a thing that might motivate them to do that kind of work and started to think about why we would want to do something like that. So thinking about that as a neuroscientist, my background's in neuroscience and healthcare data, I was thinking about what's happening in our community, in our state, in our region. Again, I'm from Kansas. So I approached the people that you see here, Kansas Biological Survey scientists, the Kansas Water Office, USGS, our city, the city of Wichita, and developed a project in collaboration with those folks around the things that are most concerning to our region, and it's all about water. So there's actually an article that's come out this month in the NSTA's The Science Teacher in the April-May issue called Messy Data, Real Science. And it's all about that project, and I wanted to share it with you because it's available for you to do it in your area, and it's all about starting with the why, and equity in science education has to start with the why. Like, why do we do what we do in science? And making it relevant in our own community, in our own identity. So I want to introduce you to Jacob. Jacob's one of my students who, doesn't really like school, kind of checked out even though he's really brilliant, but he's a star basketball player and had a lot on his plate. So here's Jacob. Sure, love to show you that. Our kiddos here, this is our original team from 3 years ago when we started this project idea. A couple years ago, this is them out at our local reservoir with USGS. And one of the things that I learned about developing STEM identity, which is what this project's really all about, is that science really is a team sport. Married to the football coach at our high school. He teaches right next door to me. And I always envied how he was able to motivate kids to get out and do things after school and on weekends. And I thought, man, that's the way science should be for these kids, because they've got a lot to offer the world. They've got some great solutions and great capacities and abilities. So we put together this team, and we watched STEM identity develop in real time. So I'm going to introduce you now to Cora, who's going to talk to us a little bit about that. So again, this is all about getting kids to develop STEM identities. I couldn't get them to develop on their own. They were too scared to do it alone. They were kind of intimidated by not only the science, but the scientists. And they didn't see themselves in those scenarios standing on their own. So it's a way to scaffold building STEM identity. So I got this idea back in 2013 whenever I read this Time magazine about millennials, the me generation, and really thought about how social media plays a big part of their lives and how we could use that to help them show the world the important work they're doing, because they are changing the world, and they will. Kids today, if I'm talking to you as a young person, you know, you don't really have leaders. You have the idea of the world as it should be, and you're willing to overturn the way that it is, which is great. So we need to start with that kind of why, your why, find those patterns, and then globalize that to the big problems that we have today. And that's what Jacob and Cora have been doing now for a few years. They've actually recruited hundreds of other kids to jump on that research wagon with them. They're very earnest and optimistic. They're dreamers, and they carry a huge population of kids with their excitement. So with all that built now in our school community, we've got kids now who are ready to step out and claim their own niche. Like, now they know, I want to be a geneticist, or I want to work in biotech, or I want to work in healthcare data or limnology. And they're claiming their own role in their own STEM identity. So this is, I taught Jacob and Cora when they were freshmen, along with all those other kids you saw. And here they are now as upperclassmen, and they're standing on their own as scientists, shoulder to shoulder. They've gone to lots of conferences. They've got lots of research that is reviewed by the state of Kansas, by the EPA, and they're on email lists back and forth with those people. So it's quite fantastic experiences for those kids. So that's just what I wanted to share with you today about how to build STEM identity by scaffolding it with that group. Peer recruitment is the biggest piece of that. Those kids recruited each other and formed their own football teams to get out to the water every day, every other week. They come back to the lab and they test it. So I'm going to share now the control of this for Ms. Claudio, who's going to tell us all about how to manage a lab day by day.
Thank you, Ms. Hammett. So to follow up with the next piece, once again, my name is Jennifer Claudio, and I'm at Oak Grove High School. And so in continuing teaching research for students, I'll be talking about lab management and student leadership, two components which actually build upon the idea that Ms. Hammett has drawn for us about STEM identity and the part that we are all part of a science team, whether we're teachers, students, supporters, or mentors. And so throughout this week, you've participated in panel talks, you've participated in virtual experiences where you can see the effects of some of this science. And a lot of times that's going to begin in your classroom. So you need to begin by establishing an effective lab space and take initiative for decisions about your project. We've got a team space that's been built, and whether or not you want a leadership role, many people are thrust into that. It's up to the students to take initiative for decisions about those projects. Decisions can be guided by teachers, and teachers can provide some information, but it really comes down to the student finding that identity. Going back to the basketball example that was painted earlier, you have different positions at play. And likewise, each student has a particular role where they can fill in that piece. Your projects might be driven by the materials you have available as well as your workspaces. Currently in quarantine, that might look a little bit different, but our resources are still available. And so to choose a project, it might be driven by what do you have. Just yesterday, there was a talk where a panelist described model organisms that could be used for life sciences, and he mentioned pill bugs. And those are very commonplace, and most of us can step out and find a few under a rock even, and that's even a nice starting place to start asking those why kinds of questions. As your project begins to develop, you're going to need to maintain lab upkeep. If you're a teacher, you might start with only one or two students, and that's easy to have one or two students. They don't take up much space and they don't take up much of your resource. But as your cohort starts to grow and grow and grow, it becomes a little more difficult. And as a teacher, you've got to push your students to take on the leadership roles of managing their spaces and taking control over what they are going to do, the decisions that they had made. And for a student who's now starting on a project, it's important to prioritize that documentation in a lab notebook. The lab notebooks, it can be electronic if it's appropriate for certain projects, but a physical notebook is very important. Notes don't take themselves, and students need to decide what is important to track that process. Students who have traveled to different laboratories will need to keep track of that information. And possibly if there's a patent in the future that's coming up, it's going to be important for legal purposes as well. But at a certain point, you might get to a rut in developing a project. And so that's not the time when a student should stop and give up and hope for something to happen. Hoping for something to happen isn't what drives the project. And so at that point, a student needs to take the initiative of seeking professional connections. But as a student, it could be a little bit difficult at first. And so what can a teacher do? Teachers can invite guest speakers. At Oak Grove High School, we started a society for our, what is it? A society for our students speaker series. And so we invite guest speakers. We've invited scientists who can come in and have a talk. Teachers can provide templates for students to write professional emails. Some of our students are used to talking in a mobile way. And so the formal method is slightly foreign sometimes. And now more than ever, teachers can use technology, virtual experiences. Virtual reality is a growing area. And so these opportunities that get presented to students are going to be where students take the initiative to make that connection actually meaningful. So what can a student do? Attend those actual public lectures. So whether it's on campus at a high school or whether it's at a university, be a part, take the initiative, make the effort to actually be there. Read science articles. And in the next slide, I'll be discussing a resource for that, but also for students to join citizen science projects. And I'd be happy to talk about some of my favorite citizen science projects later if anyone's interested in that. But it's important for the students to actually reach out to make those connections from any of these opportunities that get presented. I mentioned research articles, and it's important to seek support from experts, but a lot of times you don't know where to start. And so I'm a strong advocate of the Science News magazine. Science News has many short articles and a longer feature article, and there's also Science News in high schools that has a lower Lexile reading level. So it could be easier for a student to skim if they're maybe a middle school student or if they're at a lower reading level in general. It's also very supportive of our English language learners to help provide that equity and accessibility to students who are really developing language. So a student might set goals to read 3 to 5 short articles each week. And then the Science News Educator Guides, which are also published, can be used both by teachers and by students to find ideas like that. I've got students who've developed projects based on these. So a recent article was about Arctic browning, and one of my students was very interested in reflective indexes of the plants and what was going on in there. And so that led him to actually do research at one of our local universities where he was allowed to gather data. So I have a strong connection to the Science News magazine. So even as a kid, I didn't know at the time that I'd be affiliated with the SSP later, but I would just lay in the sun in my favorite little sunny spot and read these articles. And now I'm advocating others to do that as well. So these primary sources are a way for people to access where is the research happening. Maybe I'd be surprised and find that a local university is actually doing this kind of research, doing these kinds of processes that might interest me. And all it takes is sending an email or trying to reach out and seeing if maybe an assistant is needed in one of those areas. And lastly, where does this come down to? So I ask my students to extend their STEM identity beyond the competitions for prizes. We enjoy competitions and we have an anxiety associated with them, and winning feels good. But winning at a competition isn't everything. That identity needs to go beyond that. And so my students will enter into conferences, or rather they'll participate in conferences. They'll share what they've learned, what they've explored, and then we find relevant communities. So the ones I've listed here, the ASGSR, the Entomological Society, Biomedical Engineering Society, all of these are ones that are relevant to my students. But what you and your students, or what you as a student might have in your area, might differ. And whatever interests you is somewhere where you can share. And you're not being judged for a prize. You're having experience where you can actually be a part of that community. So whether you started in a leadership role or not, you actually are a leader in that community. And so with that, I mentioned conference presentation and participation, but there's more that a student can do to join the STEM community. And so with that, I'm turning it over to Ms. Gazda.
Thank you, Ms. Claudio. Like she mentioned, you can take your STEM identity a lot further and be a leader in different ways in competitions, and publications are one of those ways. So again, I'm Katie Gazda coming to you from Arizona, Red Mountain High School, and I'll be talking about student authorship and publications. Like Ms. Hammett mentioned, it does start with your why. Why even prepare to publish? Well, by doing so, you're going to be sharing your study with a completely new audience. And from that, they're going to bring in their perspective and give you a lot of feedback that's going to help you grow and to really challenge and make your project the best that it can be. The other challenge that it comes with is you're going to be making a piece that is a standalone piece. I'm sure as students, you are all very familiar with presenting, either standing in front of a poster or in front of a PowerPoint, and you can kind of read your audience, and you can see where they're getting confused, or if you're talking to a judge, they ask you a question, and it kind of guides how you present the information that you have become an expert in. When you do a publication, it's different. The publication stands alone by itself. So you really have to polish it so the communication is very clear and you get all your points across so that your audience really gets what you are trying to share with them. So how do we go about publishing? Well, you definitely need to review a ton of research articles. I'm certain as students who do this and as teachers, they share them with you. But I've seen with my students, we tend to focus only on our topic, which only gets you exposed to kind of a certain style. Go outside of your topic. Read articles from every subject you can. It's going to give you a lot of different styles and formats, and it's going to start helping you develop your own. So when you move on to writing your paper, you're going to pull from all those different places the things that you really solve clarity and that resonated with you. You'll come up with your own style and voice so that you're really going to communicate your passion for your study through your paper. Then once you have your paper ready, submit it. And this isn't informal, but submit to everyone, to your peers and outside experts. And certain as students, you guys peer review and help each other. And you probably share with your mentors and your teachers. Go outside of that. Go and challenge yourself to share your baby, your research with someone else, especially experts who might be in different fields. This was a huge help for my students when we did our publication 4 years ago. We went to our newspaper and magazine department, who are amazing. And they became the editors of our publication. And my students were getting feedback that was totally outside of what they heard before. And at first, it was uncomfortable, but then they really started to appreciate it. They completely pushed their paper to a new level, to a wider audience. And that was a huge help. Once you have your paper ready, where can you publish? Here's a list of some of the journals that I've been exposed to over the past year, talking to other research teachers and from my own students. The first one is the National High School Journal of Science. This is targeted towards high school students, and it's student-run and peer-reviewed, which I love. This is a great place to get started. The Journal of the Student Research is an academic multidisciplinary journal with a faculty review. Before, they were only accepting projects from AP research students, but this year they're going to open it up to all high school students. So I very much encourage you to get on that. Then we have the Journal of Student Science and Technology. This is a scholarly publication that has PhD review, but they are open to high school and college ideas and research. The Journal of Emerging Investigators is an open access journal that focuses mainly on biological and physical sciences for middle and high school students. So if you're a middle school teacher or middle school student, please jump on that one. That's a fantastic opportunity for you before you enter high school. The bioRxiv is an online archive that focuses on servicing preprints. Preprints are kind of cool because they're scholarly papers that you can publish before you've had formal peer review. So that's another wonderful place to look to publish your own research. And then I did add the Warm Breeders Gazette because a lot of us kind of work with C. elegans for model organisms, and they focus on brief articles that focus on C. elegans. That's a wonderful resource if you are research involved C. elegans. And of course, my last and most favorite publication is your own school's publication. Our school took on this challenge 4 years ago because I had research students who were fantastic, and then I had them in second year, and I was like, what else do I have to teach them? I kind of gave them my wisdom. So I had a conversation with a colleague who really kind of helped draw out what we could do next. And he got me talking about what scientists do and where I want to see these students in years. And he's like, well, then have them published. And I was like, we can do that. He's like, why not? And it was that little prod that got us going. And I reached out to our magazine team, and we were very fortunate. They are incredible. And we got a grant, and within 4 months, we published our own journal. We even got an official ISN number from the Library of Congress, and it's an official publication. You can do this too. All right, like Ms. Claudia said, go be a leader. Start that at your school. Encourage your teachers, support them. And if you don't have the resources, like I said, we're so fortunate with that magazine team who helped us, then it could just be the initial start. You can make those articles and you can go copy on the Xerox machine at your school and hand them out to everyone you can, and it will grow from there. So I encourage you all to find that STEM identity, go be leaders, and go share your research to publications.
Great. Thank you all for that insight and the inspirational advice. We really appreciate it. I am now going to take some questions from the audience, and we will get as many questions in as possible, but audience, if you still have additional questions, please submit them. So we'll start off with Amy for the first question. Amy, how can teachers make science research seem less intimidating to interested but busy students?
This was my great challenge because kids have so many after-school activities that they're a part of already, and then they care about their grades, and they have tons of in-school work that they have to do that they're held accountable for by their teachers and their parents. So it's really, science research is in competition if you don't have a class that's set aside for that, if it's an extracurricular thing. So what I found is the only way that I have found that has been really successful for us is to make it a team sport, to make it teamwork. So my students go out after school together. They get together on Saturdays and Sundays. They'll be texting me in the late evening saying, look at what I found in this journal or in this article. And they have full ownership of it because they're pursuing first a relevant question that is unknown. It's not prepackaged curriculum. They're not rehearsing what's already known and regurgitating it. They're learning everything that is known because they're going after something that's not, to solve a real world problem right where they live as a team. So that's highly motivating. And so that's the place to look, is look around you. Look at what science researchers are doing in your area, in your community, and how can you set up a feedback system to benefit them and allow your students to apprentice and work alongside of those scientists. So thanks for asking. It's a great challenge, but it's one that's easily overcome if you reach out in the community.
That's great. Thank you, Amy. I want to go join a research team myself right now. Jennifer, do you have anything to add to that?
Yeah, I wanted to chime in that Amy mentioned that we're part of a team, right? And so we see that science research can be intimidating to students who are busy but interested. And so that's because a lot of the students who are going to participate in this are in every other thing. They're in leadership, they're in band, they're doing all kinds of things. But sometimes you can find an intersection of those hobbies or interests and build something together. If you are leaning towards entrepreneurship, you might work on invention sciences. If you're interested in developing new methods, there's a whole world out there. And the nice thing about science research is it's one of the only places where there isn't really a wrong answer. Whatever you do is what you do. And so you can allow that to build your confidence. You are the master of what you do. And you're likely going to know more than your mentors because you'll have a focused area where you're actually developing a project. So it might seem intimidating, but you just got to jump in there and do it.
Great. That's great advice. And finally, Katie, do you have any other words of thoughts or advice?
I was muted. There we go. I'm going to jump on what Claudia said, that it is so nice to have that weight taken off your shoulder, that you're studying the unknown. It's unknown. You can't be wrong. Go out and try it. You're never going to know what you can accomplish until you try it. And so don't fear that unknown. Go and study it.
Sounds great. Thank you all. We have an additional question here. What can I do if my school doesn't recognize the importance of student research or doesn't have the resources like school lab space available? So Jennifer, do you have thoughts on that first?
Initial thoughts on that is that at my school, we have a lot of resources, but the problem is a lot of it hasn't been used very well in a long time. And so we don't know what we have. It's almost like not having things. But as we've been growing the program over the last several years, we're piecing together what we do have, we're identifying what we have, and now we're using that. I am lucky that my school is very supportive of the science research program, but I know others who are not in that situation. And so my suggestion to that specifically is to make it a big deal, is to grow the program and earn that reputation. Once you have the reputation, the school will recognize that what you're doing is bringing the school out to the world. And I feel like any administrator, teacher, or district will be supportive of that. But yes, the main thing, find what you have. And if you don't have a whole lot, start small. Pill bugs, roly-polies, scallion onions, all these kinds of things can give you a whole world of lab research projects, even if it doesn't seem like it at first.
Great, thank you. And Katie, what about your thoughts?
I completely agree. Start small. Use what you have. As a teacher, go back in those hidden closets and find out what your school does have. And if there are no hidden closets, like I've seen at every school, then go out and talk to your community. I have been so incredibly surprised of how much when I go and ask industry if they have some leftover equipment, everybody wants to donate. Everyone wants to help education. There's great grants out there. Society for Science has a wonderful one. But look in your local community to get some of those. And it really doesn't take money, but if you feel like you need it, grants are helpful. As a student, if you don't feel like it's supported at your school, go and make it a thing. Go and find a teacher and ask them, will you kind of mentor me? Teachers love that. It's going to renew their passion for teaching. You're going to become a star at your school because you're going to start the actual like momentum to get a research, program going. So it's kind of a fun place to start not having a program. That's where we were 4 years ago, because you decide where that program goes and what they're going to focus on. So not having resources can be a blessing sometimes for a research program.
That's great. And finally, Amy, do you have additional thoughts on that?
I don't think that my school district doesn't support science research, but we didn't have room in our schedule for it. So one of the things that I tried out, and it's been great for my kids, is reaching out to the local universities, to the local USGS office in our city, actually. So the kids now are interning and apprenticing with USGS. They're working in the city's science lab at times, and also those science researchers. They work with one researcher in Wichita on solar panels, another one on biotech, another one on limnology and harmful algal blooms. So they're working in their labs, and this was kind of interesting learning for me over the last few years to see that science researchers have to write for their funding. They don't have funding without that. And so one of the broader impacts in their funding lines, one of the things that they kind of get a gold star for with the National Science Foundation is educational outreach. So they've been very generous. And so I think it's just a matter of getting the kids to ask. So I send my kids with their research ideas to talk with people who are experts in those fields, and they've been very welcoming. And I think if you set up a feedback system where the kids are actually contributing something meaningful to those science research bodies, then it's an ongoing thing. They're just not taking everything, taking time and resources, they're giving back. So making sure that your kids are doing some authentic science that feeds the research body and really helps that research body and that researcher along in his or her career has been really beneficial.
Great, thank you. I want to keep moving on because we have some great questions coming in. And Katie, I'll come to you with this question first. How can we motivate students to conduct research and keep them engaged during long-term projects?
It definitely comes to what are they passionate about. Giving students ideas have never worked, because if their heart isn't into it, then they're not going to get through the highs and lows of research. So in my research class, we always start off with, what are you passionate about? What do you care about? And most of the times it's what students think are small. Like, I care about the health of my family. I care about the local parks. And I'm like, that's not small at all, because it's important to you and it's connected to your community. What can we do to improve that? What can we do to make other people passionate about that? So finding the passion within yourself and helping your students find that is where all the great projects I've seen have stemmed from.
Great, thanks, Katie. And Amy, on to you next for additional thoughts.
I just totally agree with what Ms. Katie just said, that engaging your own identity in your own community, that's what it takes.
That's great. And Jennifer, anything else?
Yeah, one piece is that sometimes when your long-term project, you need to take breaks. And so you might start with the project in August or September or even earlier, and you get a little tired of it. But if you set it off to the side, work on a few other side projects, come back to it in a day, a week or two, if it allows, because you can't let bacteria just sit like that. But certain things, just set it off to the side and then come back to it. And then it kind of renews what you're doing. It's very important to allow yourself to take that.
Can I add in one more, just to reiterate what we said earlier? And you just helped me think of it, Ms. Claudio, is that team factor. So when you need to put your project to the side, help somebody else. That giving part and being part of the team and supporting each other, that's another huge way to get motivation. Amy definitely talked about that, of how she has that great research team. And that's a huge motivation. Kids want to, not just kids, everybody, human beings, we want to be part of something. Make research a team, and that will absolutely motivate you as a student, and teachers, that will motivate your students.
Great, thank you all. All right, so coming back to you, Amy, first for this next question, and it is from a student asking about how to find mentors on their own.
So one of the things that I would highly recommend as a student that you would draft an email, because I feel like that's courtesy to draft an email instead of calling or showing up in person to give someone time to think about their schedule. But draft an email, go to your local university or your local college website, look at who's studying what and why they're studying it. Researchers tend to work in the area where the problem is. So if you're talking to someone local, they're typically working on a problem that is local. They may be working on something that's larger globally, but they're in your region for a reason because there's some access to some data or some field work in that area. So if you go to your local university or your local college and you find out who's working on what, and send an email and just say, hey, I'm a high school student or I'm a middle school student, and I'm wanting to work on this problem that you're working on. And this is what I think I can do to help, to maybe do some primary data collection. And I wanted to know if maybe I could come to your lab and say hello. And that's a really great start. They will take you under their wing. Come ready with lots of reading done so you know what you're talking about before you go.
All right, and Jennifer, a couple quick additional comments?
Yeah, and the worst thing that can happen is that a person says no, and that's okay. It's not against you. Sometimes they're just overwhelmed and maybe don't need the help right then. It's totally fine, and you can always come back again later. There's plenty of options for you out there.
Great. And Katie, I'll leave you out a few.
Great advice, absolutely wonderful advice. Professors are usually where we start, but I do encourage you, look for experts and mentors outside of academia. One of the best mentors I've seen was a plumber. A student was interested in Legionella, an infectious disease, and was really focused on talking to infectious disease physicians and researchers. And I was like, well, where's it found? It's in the pipe. So we actually found the plumber of the year for Arizona, and she worked with him, and she got so much more insight because he was, in the trenches, per se, and he knew a ton, and it gave her a totally different perspective, and that's what really took her project, just bolted it forward. So seek experts in the topic, but it doesn't always have to be academic.
Great, thanks, Katie. That's a great example that you just gave. Okay, so we probably have time for 2 additional questions. So let's talk a little bit about a different type of mentor, a student mentor this time. And this question is asking, do you have, how can student mentors get their peers involved? Are there any tips and tricks to doing that? So let's go ahead and start with Jennifer.
Major theme going on is that we're all part of a team. And so as a team, you just bring people on. So, hey, this sounds fun. Show them that you're having a good time. And it's okay. Sometimes, not every time is rainbows and bubbles. And that's okay, because now you're building an experience together. As you build that experience together, you actually grow together. Science is fun. There's a whole world of things you can do out there, and it's almost like a gateway to everything else that you can do.
That's great. And Katie, coming to you.
One of the things my students wanted to do was this exactly, mentor other students. So we started a club. It was Operation Nerd, Navigating Experiments in Research Design. And we went and visited our local junior high and elementary students. And allowing the high school students to now become the experts really drew in everybody. It was fantastic. So that mentoring, when you just invite people to do stuff, they want to be part of it. So give them the invitation. Even if it's starting a club or just holding an after-school thing real quick, give an invitation to it, allow people to become D-bar, that team we're talking about all the time.
Great, thank you. And Amy, do you have any other words of advice?
I guess the last thing that I'll say is that I put my kids on social media so the teenagers see what they're doing, and that's a huge draw. And so my kids mentor other kids. Jacob and Cora will take you in the lab, will take you out to learn how to take the samples out in the field. They do all of the mentoring for me. I don't mentor any new kids. They do it all. And so social media plays just such a big part of their lives. So if you get them mentoring other kids, that's the place to start.
That's great. And it looks like we're about out of time, so we'll go ahead and get wrapped up with that last question. So first, I'd like to thank the audience for joining us today and asking really thoughtful questions. And on behalf of the Society and the Regeneron ISEF community, Amy, Jennifer, and Katie, we really thank you for your time and for sharing your expertise with so many other teachers and students. And finally, for being such an involved part of our educator community. High school science teachers and research teachers out there, please head to the Society website to sign up for the Science News in High Schools program and the Research Teachers Conference Lottery that are both open right now. We would love for you to become a part of our educator community too. So thanks again for sharing the week with us.